Hello, good morning viewers. In this tutorial, we want to resolve this compound fraction into a partial fraction. But before we start, there are two important things you should know. The first one, whenever you are given a compound fraction to resolve into a partial fraction, always observe the degree on the numerator and that of the denominator. If the degree on the numerator is greater or equal to the degree on the numerator, you have to carry out a long division first. But in this case, you can see the degree on the numerator, we have total equal to 4 because this is 2, this is also 2. And the highest degree you can see here is 2, 4 is greater than 2. Secondly, you should also observe the nature of your factors. If they are reducible, try to reduce them. Otherwise, you continue. I have solved so many problems under partial fraction. You can check on my playlists. But considering these two factors, this is reducible, but this is not. Therefore, we can go ahead and reduce this one. And this quadratic function is also reducible. So let us reduce this and this all together. Our numerator is 3x squared plus 2x minus 1. You can factorize it as x plus 1 multiplied by 3x minus 1. So our compound fraction becomes x plus 1 multiplied by 3x minus 1 on the numerator, and under the denominator the first one is not factorizable, so we leave it that way. X squared plus 1, then multiply by 2x squared plus 3x plus 1 can be factorized as x plus 1 multiplied by 2x plus 1. So we have x plus 1 multiplied by 2x, then plus 1. All right, look at our numerator. We have x plus 1. And in the denominator, we also have x plus 1. So they cancel out. What we have left is 3x minus 1 divided by x squared plus 1 multiplied by 2x plus 1. Now this is what we have to split into partial fraction. Because we have only two factors, we are going to obtain two fractions. So this is equal to the first fraction plus the second one. The first fraction will contain its denominator as the first factor here, which is x squared plus 1. X squared plus 1. And the other one is 2x plus 1. 2x plus 1. Alright, to obtain their corresponding numerators, you have to also observe the nature of these two factors. The numerator is always a polynomial of 1 degree less than the denominator. The denominator here is quadratic. 1 degree less will be a linear. So the general form is ax plus b, where a and b are all constants. This is linear. Therefore, the numerator will be 1 degree less, which is going to be just a constant. And this time around, we are going to use c since we have a and b. We are moving. Now we are going to multiply each term by these two factors in order to clear the fractions. Multiplying the left hand side by these two factors, we will be left with only the numerator, which is 3x minus 1. And to the right, we have this multiplied by these two factors. X squared plus 1 will cancel x squared plus 1, leaving only 2x plus 1 multiplied by ax plus b. So we have ax plus b multiplied by 2x plus 1. Then we add. Take this, multiply by these two factors. 2x plus 1 will cancel 2x plus 1, leaving x squared plus 1 multiplied by c. So we have c multiplied by x squared plus 1. Now we are going to expand these brackets. To the left we have 3x minus 1, and to the right we have ax multiplied by 2x will be equal to 2ax squared. 2ax squared. Take that again, multiply by 1, you have ax. Then take the second term, b multiplied by 2x will be 2bx. 2bx. Take b again, multiply by 1, you have just b. Then the last one, c multiplied by x squared will be cx squared. Then c multiplied by 1 is just c. All right, we are moving. To the left, we have 3x minus 1. And to the right, we have, let us bring those with x squared together. We have one here and we have the other one here. And we can write them as 2a, then plus c, so that we factor out the x squared. Then let us bring those with only x. One here, the other one is here. We have a plus 2b, a plus 2b, all multiplied by x. We just factored out x. Then lastly, we have our constants, b and c. b plus c. Now we are going to solve this equation by relating the coefficients. Let me start with x squared. The coefficient of x squared to the right is 2a plus c. So our first equation is 2a plus c. And what is the coefficient of x squared to the left? Nothing, because we do not have any x squared to the left. So this is equal to 0, our first equation. The coefficient of x to the right is a plus 2b. So we have a plus 2b equals the coefficient of x to the left, which is 3 here. This is our second equation. Now let us form the last one using constants, b plus c. b plus c equals the constant to the left is -1. And this is our third equation. Now let me use this first equation to make a the subject. From equation 1, we have 2a equals -c if c crosses over, and a will be equal to -c divided by 2. And I can call this one equation number 4. Now we can plug equation 4 into equation 2 because we have a here and a is equal to -c divided by 2. So from equation 2, instead of a, we can write -c divided by 2, then plus the second term, which is 2b, and to the right we have 3. We can multiply each time by 2 to clear the fraction. -c divided by 2 multiplied by 2 will be -c, plus 2b multiplied by 2 is 4b. To the right, 3 multiplied by 2 is equal to 6. Now this is another equation we form by substitution. Now we can bring equation 3, join it to equation 5, solve them simultaneously. We have b plus c equal to -1, but I can write it as c plus b, commutative, it's all the same. C plus b equals -1. Remember, this is equation number 3. We want to add them together to eliminate c. -c plus c is 0. 4b plus b is 5b. To the right, we have 6 plus -1, which is 5. We are looking for b. We can divide both sides by 5. Therefore, b equals 1. We have just obtained one of the values we are looking for. Now we can plug it back into this equation number 3 to obtain the value of c. From equation 3, you can see that c is equal to -1, -b if b crosses over, but b is 1, so we have c equals -1, -1. This implies that c is equal to -2. Another value of 10. And the last one we want to find is the value of a, which is -c divided by 2. You can see it right here. A is equal to -c divided by 2, but c is -2, so a will be equal to -2 divided by 2, and finally a is equal to 1. This is another value, and this is the last one. Now what do we need to do next is to substitute a, b, c in these fractions. You can see them right here. We are going to substitute the values of a, b, and c there to obtain our partial fractions. So now let me copy that. So I have just copied the equation here. We are going to substitute for a, b, and c. For a, we can see that it is equal to 1. So we have 1 multiplied by x, which is the same thing as x, plus b is equal to 1. You can see right here. So plus 1 divide by x squared plus 1. Then plus c is -2. You can see right here. So this is negative instead of positive. 2 divided by 2x plus 1. And this is the partial fraction of this compound fraction. And this is all I have for you today. Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.